Okay, so I am very pleased to be here today to tell you about a project that has been in kind of incubation for quite some time. And in fact, it's kind of the thing that I came to Dundee back in 2004 to actually do. So these wonderful people, some of whom are in the audience, oh no, I'm going to have to go very quickly. So as we all know, computational science is all about running code. And there are some really wonderful tools out there for allowing you to actually install the code on your machine and run it. But bizarrely, you need a web server to actually increase the citations of your tools, because people can't install the tools themselves and run them unless they want to run the tools lots and lots of times. Somebody even did the research to check this. It's not a bad paper, actually. But really what we're thinking about here is getting some input data and parameters, stuffing them into a command line that runs. It could be a very complicated command line that actually the input data and parameters sits in a file somewhere. That all sits at the back end, and you've got some tightly coupled front end, which is really the important thing for the people to use. There are constraints because you don't let everything run on the server. And of course, your system administrators really care about you actually making sure that the tool that you're running is actually running correctly. So you may have a Nextflow profile, something like that. And that depends on the input as well. So getting all of that logic right is pretty hard. And actually what you really care about is this bit. That's what you put in the paper. You don't put this bit here, but your system administrators really, really care about it. Also the maintainers, the people who will be looking after your tool after you. The other thing that people really want is a standard API client, so they don't have to go through the website at all. They just run your tool directly without installing it, magically. And this is something that I was kind of interested in doing when I came to Dundee. And really, we're asking the question here, can we decouple the tool execution from the web server development? Because that will make things a bit quicker. There are people who are really quite interested in this being done. Stuart McGowan, who's sitting in the audience in the middle, he looks after the Dundee Resource, the UKRA BBSRC funded project, which is hosted in Dundee. And it's basically the collection of many web servers developed by many students and postdocs over many years, lots and lots of languages. They all run on our cluster, which is just about to change to Slurm, so that's going to be fun. Maintained by one postdoc. Yay! But that's reality. So if we can simplify this, that would be great. The other thing is, there's this tool here called Jabbers, which I think I might have talked about at BOSC years ago. So Jabbers is a portable executable as a stack framework. And this is kind of the idea of being able to take executables, package them, run them locally, and then connect them to either a command line or to, in the case, the tool I developed, JalView, because people who use JalView really don't want to install command line tools. They kind of want to chuck the data in, grab stuff from databases. And ideally, what we'd like to do is to have those tools be able to be installed locally on your machine. And I'm not going as fast as I did in practice. So this was the Holy Grail. In fact, some of you will remember semantic service discovery was the thing everybody was trying to do. And maybe we'll get there. So I developed the first version of JalView's web services in 2005. That's still running. This thing, Jabbers, we released in 2010, both SOAP clients. And finally, we will release, or we have released Slivka, and JalView version 2.12 will be running this. So this is a Python stack. You can drive it with curl. You don't need anything special anymore, because the SOAP client was a pain in the proverbial, if you excuse my French. The other problem was that we couldn't add new tools to this without coding. And what we wanted was something where you did not code, the minimum amount of code possible. And so this is what we've really focused on. We've gone really back to basics. MIME typing, simple YAML, that's it. We want to be able to also chain services. So that's what it's capable of. So what we'd like to do is to persuade people to move from doing the conventional bespoke web app, where you've got tightly coupled front end, special API client that's not compatible with anybody else's, to something where you have a canned web API, a REST API from Slivka, and your web app is also talking to that. The magic is that we've got a configuration which your administrators can edit. They have a standard system which is well tested and well maintained. They don't have to go into the code and fix things. Really, what this is all trying to do is going from a set of input data. So those are like the orange here, the input and output, with a few parameters, but then there are some, can I bring that over there? If I can find it. Okay. I had an even more complicated version of this diagram. I don't know where the mouse is. There we go. Sort of there. So getting even the path to the program right and everything else, that's a problem. It could be a container. You've got to make sure you've got to get to the container there. Extensions matter for command line programs. You would not believe how much fun we've had getting particular structure visualization tools to read formats they know how to pass if you didn't get the extension right. It's hilarious fun. So I'm not going to go into too much detail because we don't have that much time. So what Slivka gives you is a framework for creating a service with a YAML file. You can run your service. You have runners, which you can configure. You can feed configuration into those runners as well. Configuration can be dynamically generated based on the input. And if my mouse is still there, this is the diagram that sits in the abstract. And essentially we can have either, I mean, at the moment we have Python clients, Java clients, or just JavaScript or curl. And the basic cadence is you can discover services, upload your input, run a service, monitor the status, and eventually download the output. Some interesting things that we discovered were that to minimize the complexity, we didn't want to have to ask somebody to install a complicated to administer database, so we've just kept with Mongo just for simplicity. But there's a curious thing about latency in different parts of a system. So schedulers can take a long time to actually say, yes, my job is actually on the system and it's being accepted. So we had to work a bit on decoupling the scheduler and the front end so that we could actually get back information to the client to say, no, yes, your job is safe. It is going to go somewhere at some point, and it's not just going to crash weirdly. And of course, before the global interpreter lock change in Python, we were having a lot of fun learning about Python green threads as well. So we have, in addition to Slurm and Grid Engine, also support for LSF. That was thanks to Kieran McCullough and Thomas Downs at Genentech, because that's what they run internally. Dundee hasn't got LSF. We have a slightly different system. So this has allowed us to harden things a bit. And so when you install Slivka, this is the standard structure of the application. This is actually changing a little, but the idea is that you can add in a few Python functions yourself, which can then be called from the YAML in order to do things like count the number of sequences and lengths of sequences in a faster file. So you can then start to use those evaluations and expressions. And this is also important for validation. So very quickly saying your file format is actually valid. You want to do that immediately on submission of the data. You don't want to do it after the job's gone to the cluster. That just wastes time. There is a fully documented JSON schema, which works very nicely in this JSON schema viewer, which if you get the slides, you can take a look at. Usual stuff here is we've been inspired by a lot of the existing representations of tools, and we would like to make sure that there is some kind of isomorphicity between what we have in Slivka and CWL tool definitions and Nextflow definitions, and also even Galaxy definitions. The critical thing is this mapping from the inputs to actually what becomes the command line. So that's sort of the magic. It's the generation of executables. The other thing also is this EDAM, the ability to insert EDAM ontology terms. And that's kind of says this service complies with some sort of contract defined by the operation of the term and the actual function of the tool. This is a very much a nascent stage, so I'm very happy to show the terrible code that we have currently that's doing that, and I would love to know if we can do better. The ecosystem as it stands, base Slivka comes from pip and conda. We have Docker installs. I think there is a Docker image that's possibly going to be updated soon. Stuart is nodding. I couldn't get at it today. Interestingly, we did actually provide all the tools that Slivka Bio supported through Conda at one point. But of course, all of our Conda dependencies promptly died. They all crashed, and even better when we were trying to get it running on Apple Silicon. So Stuart's been spending the last couple of weeks just actually making sure that we can say, yes, you have a one-line install of Slivka. The Slivka website, which you may be able to view, gives us the service status, and that's real time. So we have tests defined for each service which get run, and they get run out of bands. So when you go to the usage statistics, you aren't seeing all of our test runs as well. It really is actually external users. And we have a very simple sort of form-based auto generation, so you can upload data and run the services for yourselves. The other thing that happened was that Thomas has been playing with JavaScript a lot. As some of you know, he is going for it seriously. He's just updated it, I think, to the latest React framework. So Czekolada, which are there any Polish speakers in the audience? Okay, so Slivka means plums. Czekolada is chocolate. So Slivka. So there's this Polish sweet which is a plum wrapped in chocolate. So this is the idea behind this. So basically, actually, Czekolada acts as a local proxy to any Slivka server, but then it stores the job details and history in the browser. So you can just spin up this and start sending jobs anywhere, and it will keep track of all of your IDs and so on, and produces rather beautiful forms as well. This is all very much a work in progress. We've been trying to get the paper ready to go, and of course, if we push the paper out, we actually need things that work and don't not install. Our chief tester is sitting here in the second row, Jeff, who asks, "What's Docker?" and other interesting things. It's good to have somebody who is really fresh to the project. We have this interactive installer. This is very new. We've just been trying it out. The other thing was that, so Javier Oetges is in the audience. So he was actually a guinea pig for running, for seeing whether you can actually separate the development of the web service from the development of the website. So Javier developed the code, he developed the front end, and then Stuart developed the back end with Slivka. And I don't even know where that's installed on the system. It was a surprise that everything was working. It was great. Do check it out. That's a 3D sig thing, but yeah. So Slivka is about making tools accessible. Am I within time? Ish. Okay, 1 minute. Right. The idea is that we can get a standardized web system that ideally actually can mirror and federate as well. We have ideas. I don't have slides for it. I would love to be able to interface. I see this as like a sanity public-facing version of what you are running at the back end. So all these amazing workflow management, data management systems, but they are not, you can't just expose them on the internet. We'd like this very small hardened component that allows you to essentially act as a firewall to allow people to run things in the public. And with that, thank you very much. Does anybody recognize this logo? But, yes. Thank you.
Hi, thanks. Just a curiosity, why Slivka? Why did you call it Slivka?
Well, some of that's a beer discussion, I'm afraid. And it would involve some discussion about Polish colloquialisms as well. Mateusz told me that it was the nicest space that was available on PyPy. And then he probably didn't actually upload the package to PyPy to reserve it, but it is still free on PyPy. So we were just looking for a short name. We had some variously bad names like PBOS. I mean, there's a history of these projects as well. We actually changed the name twice for Jabos before we actually settled on that. And that was during the flight to ISMB where I discovered and I printed the poster and I had the wrong name. So yeah. Any more questions?
Yes, one question. Do you have a way with Slivka to configure it to limit the number of requests from a specific client?
Yeah,
Per
so
minute, for instance.
at this moment, we haven't included that. We've been, so that's something I need to, we need to have. And I think this can be done through the standard WSGI plumbing, because they're pretty well developed tools for this. So firstly doing like making sure, you know, fair use policy, putting the right headers in, and then saying, no, you're not allowed anymore. One of the things we were very keen on was also making sure that the system performed well, even on a fairly small server. And one of the tricky things with that is, I don't know if you've ever tried to actually soak test a front-facing web service. It's actually very hard to get enough requests in to start to overload your server, unless you do happen to have a botnet, which we didn't go towards. We saturated our internal network before we saturated Slivka, which was nice to know, because Jabba's just fell over.
Thank you.
There's a question behind.
Thanks for the great talk. I have two questions, if I have time, that builds on the previous question. The first one is, you mentioned that there are some, you can do validation of the input data on the server itself before it reaches the jobs, because otherwise it'd be a wasteful resource. But if you have a lot of users submitting their submission at the same time, all your validation run on your Flask server. So do you have a queuing system that basically push those validation in the back so you can accept new submissions in the meantime?
This is being discussed for Slivka version 1. We're still at 0.8. We were curious to see how well it performed to start with. I think we would need to do that, and we really do know. I mean, pushing it out to the Java users will be the first step there. I mean, we don't have in the order of sort of millions of simultaneous requests for running jobs there, but we do run a fair few. So I think we've got something like 1,000 or so a day. Lots more than that. I'm looking at Jeff here. I was going to try and get a graph from Stuart. Yeah, so they do get threaded off. That's all served off its own thread, so they won't interfere. I mean, blocking between the different server service threads was one of the things that we were concerned to get right. So it's fully isolated. But yeah, I would like to be able to farm that off elsewhere. I mean, right now we've actually been starting to run a lot of local jobs for our whole services, for various reasons that I won't go into, but just in order to make things performant. Just counting the number of angle brackets in a faster file is quite quick. So.
And another question, very quick. It's also, if you run a lot of service on your web server and it's available to scientists inside the institute and outside the institute, do you have a way of authenticating? So, for instance, the students inside the institute or the researchers inside the institute have a higher priority?
We have just considered this. The way we solved this before was that we would run the service that was only accessible inside the institute, that had the same configuration but didn't have any limits. But yes, it is possible. And again, we could actually do this through just a Python function that would look up the client and say, are they authenticated or not? So we've tried to be completely unopinionated about what you might want to do, and then actually using it and exploring it. So we're sort of at the beginning of our journey right now. I mean, we're saying we're forming a consortium, but really we're just a group of people who meet on Matrix.
Thank you.
Thanks for the question. Okay. Well, catch me at CoFest. Oh, there's one. Oh, Fabio has got one.
Just very quick. Thanks, Jim. So just the question about, do you have or plan to have sort of a registry for sort of tool configurations? For example, if I want to contribute with a set of configurations for tools that I developed, for example, do you have it, or do you plan to have something like that?
That is a fantastic question. So the origin of this whole business was that I actually wanted tool developers to be able to create tool definitions, or we would be able to take definitions that already exist from other systems and then be able to say, okay, these bits of, You have a CWL tool definition. We say these are the bits which are actually exposed to the outside. Everything else is internal. You just tag that and auto-generate it. So I mean, we've had discussions at previous CoFests, and I believe I'm hoping we can continue that discussion, because I think we can all of this stuff can be pretty much auto-generated. We've been being really good about actually tagging the knowledge that we have. We shouldn't need to be writing these by hand, I hope. Thank you, Michael.
Thank you.